Hello again, Algebra students. Hopefully that first video allowed you some extra time to pause if you needed to write something down that I was going too fast for, or that you could rewind if you needed to hear something again. Today we're going to look at two sections again. One's talking about tables and one talking about graphs of linear expressions. So we did this kind of in chapter 4, that last section where we looked at the equation, the table, and the graph. And that was really focusing on more so individual coordinate points. And this is going to be talking about linear expressions, but kind of the same idea. Okay, so 5.2 is using tables to compare linear expressions. Okay, so we're going to look at an example where there's a table already written, and this is on page 291 of your book. Okay, so in this example, this table is giving us the charges for parking a car at two different garages. So here we have numbers of hours, and then Gil's garage and all the charges, and Patsy's parking and all the charges. They don't actually give us the expression. The table's already filled out, so I guess the expression's maybe not the important part of what this problem is talking about. Okay, but the first question asks, when does it cost less to park at Gil's garage? Okay, so the red one here is Gil's, and it looks like Gil is less at 1 hour, 2, 3, 4, 5, 6, at 7 they're tied. Okay, so for part A, it is cheaper to park at Gil's when I have less than 7 hours, but I guess I don't know about 6.5 hours, so to be sure I'm going to say either at 6 hours or below is when Gil's garage is cheaper. Okay, part B says, when does it cost less to park at Patsy's parking? Well, we already know it's tied at 7. And then it looks like 8 on up, it's cheaper at Patsy's. Okay, so when I have more than or equal to 8 hours is when it's cheaper at Patsy's. Okay, so that's how we look at the table. Example 2 is actually going to have us draw the table, create the table. So let's take a look at that one. This problem is going to be referred to a lot in a lot of examples, in a lot of sections, and even on the test it's referred to again. Okay, so you are a manager at an office. Your company needs another copy machine, and after contacting several office supply firms, you've obtained the following rental rates. Acme Copiers offers a copier for $2.50 a month, and an additional charge of 1 cent per copy. Okay, so I'm just going to write that. Acme is $2.50 per month and 1 cent per copy. Okay, and then Best Printers, same machine, but only $70 a month with an additional 3 cents a copy. Okay, records show that your office made as few as 482 copies during a holiday month and up to 17,386 copies during an inventory month. Okay, so we want to make a table showing the costs of this many copies, so 0 all the way up to 20,000 increments of 2,000 copies per month. So we're going to use the table and then draw conclusions about which company charges less for making the copies. Okay, you can go ahead and draw that if you want. I'm going to look at it in the book because it is a lot of data, and we already did the hard part, really. Okay, so we're going to look at what we have here in the book. So we have number of copies, Acme's charges, which is exactly what we had written down, and Best charges, exactly what we had written down. Okay, so for the 1 month that we're looking at, $250 for the basic charge, a penny for copies. If we aren't making any copies, is 250 and we're not making any copies, just $70. So here's all the data. Okay, and this said just draw some conclusions. Okay, so if I'm just going to look at this, so I'm looking at up till here, 8,000 copies, it's cheaper for the best printing, right? But once I hit 10,000, it's no longer cheaper to go with the best printers, okay? So if I was the manager, what I would say is something like, well, under 8,000 or under, we should definitely go with the best printer. But if we're consistently going to be making more than that, 10,000 or up, it's definitely cheaper, a lot cheaper actually, to go with Acme. Okay, so it really does boil down to how many copies you're going to make. And that's looks like exactly what the book is talking about. We said it's somewhere between 8 and 10,000 that we're going to have that kind of break-even point. Where is exactly, is it 8,001 or is it 9,999 that they actually flip over and the other one's then cheaper? So think about, how could we find that? How could we find that exact number of copies, even though I know it's between 8 and 10,000? How could I find that exact number? Well, if we think about the fact that we want these two to be equal, I can just write an equation like I did in section 5.2 and go from there. Sorry, 5.3. Okay, so I could set up an equation 250 plus the penny per copy. I want that to be the same as 70 plus 3 cents a copy. Okay, and I could solve this. So I would end up with 0.02c, and let's see, 250 minus 70 is 180. $180 divided by 0.02. I think the book actually did this. No, I guess they didn't. So let's get out our calculators. $180 divided by 0.02 is 9,000. So actually at 9,000 copies is when they're exactly equal. So before we had said somewhere between 10 and 8,000 is where you kind of want to pay attention, but it's actually exactly at 9,000. Okay? Alright, so that's using tables to compare some data. So now let's talk about using graphs. In section 5.4. Alright, and this is on page 304. Okay, and if we look at 304, as I told you, the same problem is coming up again. Okay, so this is Acme and Best, and here they've graphed it. Okay, they've graphed the two sets of data, and we had said before that Best was much cheaper until somewhere between 8 and 10,000. And you see this, the red one is the Best, and you see that it's much lower than Acme, which is the blue one. But between 8 and 10,000, and actually right at 9, which is what we just figured out, is where they're equal. So that's why their lines are crossing, because they're equal there. And that's when best becomes more expensive. Okay, so you can get the same data as we did out of the table using a graph. Okay, so we're going to look at example 1. Use the graph to estimate the answer to each question. For how many copies per month are the costs of Acme and Best equal? Well, we already figured that out last section, and we said that was 9,000. Okay? For how many copies per month is Best more expensive than Acme? Okay, so going back over here, when is Best more expensive? After 9,000, right? Okay, so we would say 9,000 was our first answer, is when they're equal. Okay, and when is Best more expensive was the question here. And we said that when our copies are greater than 9,000 is when Best is more expensive. And question C is, for how many copies per month is Best least expensive? Well, when is Best least expensive? Well, since they're more expensive when we're more than 9,000, we know that when we're less than 9,000 is when Best will be cheaper. Okay? All right, please read through example 2. All right, so example 2, again, comes up a lot. A tortoise and a hare decide to have a race. The hare gives the tortoise a 100-foot head start, and then it gives us the 2 rates. So part A, write equations to show the distance each animal is from the starting point after t seconds. Okay. Okay, so let's start with the tortoise. We know that even after no time has passed, the tortoise is 100 feet away. Okay? And he's going at a speed of 0.1 feet per second. Okay? So this is the tortoise. And the hare runs at 5 feet per second. Okay? So now we can plug in any amount of time, and then it'll tell us how far what their distance is. Okay, so that's part A. Part B, graph equations over the interval 0 to 30 seconds. Okay? So this will be my distance, this will be my seconds. We wanted 0 to 30. So let's see, this would be 15. All right, and so let's just do the 3 points. Let's do 0, 15, and 30. So at 0, where is the tortoise going to be? The tortoise will be at 100. Okay, so let's do 25, 50, 75, 100, 125, 150. So at 0, the tortoise is 100, because you got that head start. At 15, all right, so we'll have to type this in our calculator. Oh, I guess we won't really have to type it in our calculator. How much have we gone after 15 seconds? 101.5. And after 30 seconds, 103. Okay, so that's the tortoise. Now the hare. Okay, the hare didn't get a head start, so at 0, the hare is at 0. 15 seconds, so 15 times 5 is 75. And 30 times 5 would be 150. Okay, so that was part B. Part C. Use the graph to tell when the hare reaches the tortoise. So here's when they meet. So let's make an educated guess as to what the amount of time would be. So somewhere almost halfway between 15 and 30 seconds. So like 22, 23-ish seconds. Okay. Use an equation to tell when the hare reaches the tortoise. Okay, so again, we know how to do this. We have our two distances, and we want to know when they're exactly equal. Okay, so we can solve them and see actually how close our graph was. Okay, so this is when we have the tortoise is equal to the hare. So I have 100 is equal to 4.9s. So 100 divided by 4.9 is 20.4. Okay, so we were pretty close. My spacing is probably not great, but we were pretty close. 20.4 is when the tortoise met the hare. Okay, so this section is just showing us how we can use a graph. Other things that we can get from this is up until this 20 seconds, the hare was behind. After the 20 seconds, the hare's ahead. So all those things we can tell here. Okay? All right, awesome job.